Assalamu alaikum. Let's begin. Okay, this is lecture number 5 for DSP. Okay, so these are the various representations of discrete time system. Fine. How you are going to? These are the various symbols used. Fine. To represent your discrete time systems. Fine. For example, you are adding two signals. Fine. This is the way how will you show it diagrammatically. So what does the adder do? It adds, simply adds two signals. Fine. Now here it's a memory-less process because it doesn't use previous signal. So you don't need to store your previous signal. Suppose if had been x1 n minus 1, you were using a previous signal. So then you need a memory to store it. Fine. So next you have just you have been given two signals. You are simply adding them. Fine. So that's why it's a memoryless signal, because you are not using a previous signal to store a previous signal or an advanced signal. Suppose it will have been x1 n plus 1. You will again use you will have to use a memory would have been required. But here, since you are using only the two present signals x1 and x2, no memory element is required. Then when you simply multiply some constant multiplier, it's also a memory-less process. You are simply multiplying a constant with a signal, and you get the result. Yn is equal to an xn. Not the previous signal is not used. The future signal is not future sample signal is not used. So again, memory is not required. So simply multiplying a is a constant. So it's a constant multiplier. Then you have a signal multiplier. When you are multiplying, it's just the like adder only. We are multiplying two signals, x1 and x2. Memory element again is not required. Now here you are. Then you have a unit delay element. You are delaying the signal by 1 unit. Had it been z inverse z minus k, you would have delayed your signal by k unit. In the example, it's shown z inverse 1, that is you are delaying your signal by your output is delaying your input signal. This means what? Yn is equal to xn minus 1. This means that your output is delaying your input signal by 1 unit. Then you have this as the unit advance element. Okay, so unit delay element is not memoryless because you are using a previous signal. Obviously, to store a previous signal, you need memory where it will be stored. Xn won't give you enough, so you need to it needs memory element to store the previous signal. Fine. The next is the unit advance element. It's also not memoryless. And what do you mean by that? So your output is your input, right? Plus it's advancing your input by one sample. Your output is advancing your input by one signal. That is the output. So again, now it's also not memoryless. Fine. Just a sec. Alright, let's continue. Fine, clear this? See, this is various representation of discrete time systems. How you represent discrete time systems mathematically with the help of diagrams. What is the using symbols? What is the essence of these symbols? Fine. This you almost have, all of you must have used these symbols in signals and systems, I guess. Fine. If you have if you have studied it, I hope. Okay, now classifications of discrete time systems. So as far as your exams are concerned, expect at least one numerical out of this. I mean, to check not only static or dynamic, the simpler one. Then you have time invariant, variant systems, right? You have linear, non-linear systems, casual, non-casual systems. Okay, so if your output depends on the present input signal only, so your system is dynamic, right? So what is a static system? It's a system in which the output at any instant of time depends on input sample at the same time. Output is not dependent on the delayed input signal or advanced input signal, right? Output, see, I am calculating, see this is an example. You will be given a system and you have to check the first one. You have to check whether it's plus one. Right? You have to check whether this is a casual, static or dynamic. So what you will do, see, your output is calculated at what instant? At n instant. Right? Your input is also, how it's calculated? Your output is calculated from the input at an instant only. So both output and input are calculated at an instant only. Right? Had there been a delaying element used or an advancing element used, then it would have been a, you would need a memory to store it, and it would have been a dynamic system. In static, memory is not required because your output depends on the present input only. It doesn't depend on the past or the future signal. Fine. What about this signal? Next one. Again, it's static only. Output is dependent on the input at output is calculated at an instant, and input is also calculated at an instant only. Here, neither again nor present, nor previous nor future element is used. So again, uh, you have this. So again, you have this signal. What about this? It's a dynamic or static? It's again a it's a dynamic system. Why? Because now your output is dependent on the input signal. Up to this, at that instant only, at an instant only. Up to this, were fine. It would have had it been up to this one. Had your system would have been up to this one, it would have been a static system. But this second term makes it dynamic because now you are using a previous value also. But out of this, so first you'll expand this. So xn minus 1, xn minus 2 plus xn minus 3. You are expanding the summation. Now it's a static or dynamic. It's a dynamic system because you are using your previous signal value. Right? Clear? I hope this is clear. It's easy one. Right? Okay. Next is the shift. See, uh, I have put on directly notes. See, it's really time consuming for me to type the equations. It takes a hell lot of time. So what will be I will be doing, because now we'll be jumping mostly your DSP is mathematical. It's not diagrammatical or theoretical that I will put the slides and make the show the copy paste and diagram. It's mathematical, so I have to write the equations, and I'm not a computer operator. It takes a hell lot of time to type the equations. So what I will be doing, I'll be directly say, putting my notes in the PPT. Fine, and I will be sending you video is fine. You will be getting video on the YouTube, and I will be sending you also PPT also. Fine, in the notes that section is available. I'll be sending you the PPT as well, so that you can just if this diagram is not that clear, you can just download it. Fine, and then you can just copy paste it in your in your computer, and then you can zoom in and zoom out. Fine, so that you can get a clear picture of this. If this, I hope it's clear to me, but if it's not clear, I'll be sending you PPT as well. then you can download it, fine, and so that you can get the zooming in option, fine. Then you can zoom in and check more. I will try my level best to explain this. This is the best we get, fine, because it's very time consuming for me to type the equations, and it's DSP is all about equations and math. Fine. There's hardly in last unit only you'll find some theory. Rest it's all mathematical. Okay. Okay. So let's discuss shifts in various properties. So again, if your see a system is time invariant if its input and output characteristics does not change with time. You will say that it's a time invariant system. If it's input, for example, let me give you first a practical example. For example, I need to make a cup of tea. Fine. Whether I make a cup of tea at 10 a.m. in the morning or 6 a.m. in the evening, time is going to remain the same. Fine. Let's take other example. I am recording this video lecture. Whether I am giving this video lecture at 12 in the noon or at 3 in the afternoon, time is not going to affect. So these are all what? These are all shift invariant or time invariant systems. This is what I mean. See, in practicality, in mathematical term, I supply a signal xn to the system and I get an output yn. Fine. Then if I delayed my output by k units, fine. Sorry, if I delayed my input by k units, the output should also be delayed by k units only. It should not be delayed by more or less than k units. This is what I mean. Right. So if its input and output characteristics does not change with time, you will say a system is time invariant. Fine. Okay. So what I did, see, this xn is supplied to a system and you get yn. Then xn minus k is you should get yn minus k. So you'll be given you'll be see, you will be giving an example, a system, for example, the simplest one, yn is equal to xn minus xn minus. You have to check whether the system is time invariant or not. Fine. So what you will do? What is the first step? You will first delay this signal. You first delay the input by k units. So you will delay the input by k units, and then you will represent it by yn comma k. So what I am doing in yn comma k, I am delaying the input signal by k units. So xn minus k minus xn minus k minus 1. Simply, I just delayed my input signal by k units. Now, in equation 1, this first step is over. It's simple. You just delay the input signal by k units. Now, fine. Now, in equation a second, what you do? You just replace n by n minus k. In equation 1, you replace n by n minus k. So replacing n by n, you will get yn minus k is equal to xn minus k minus xn minus k minus 1. If your yn comma k and this thing yn minus k, if they are same, your system is time invariant. Fine. If these two things, so see, first you will be given a signal. You have to delay this input signal by k units. By k units. So output. Your y and denote it by yn comma k. So yn comma k is equal. Then you replace in equation 1. You replace n by n minus k. So it should be time invariant. Time invariant system. Okay. Here is another example. T is, what is T? T is a function of system. See, T. You get, when you supply xn to the system, your output will be T of xn. That is, in another words, it's yn. Fine, it's y of n. Fine. So T is what? T is a you can say it's the response of the system. Okay. See, I am supplying xn to the system. So I represent the system by T. So system T is what a system does to the xn, and the other is yn. Just the terminology what we use. See, now we have another example. T of xn is equal to a xn plus 6. Fine. So what you do? First step, you just delay your input signal by k units. You will get axn minus k plus 6. In the next step, what you do? You just replace n by n minus k. So replacing n by n minus k, you will get yn minus k is equal to a nx minus k plus 6. So you see both these things are equal. So it's a time invariant system. Okay, now another example, yn is equal to xn cos omega n. So first again, delay your input signal by k units. So you'll get xn minus k cos omega n. You have to delay your input signal by k units. So you have to only delay x of n. You are delaying your input signal x of n. You can't delay this. Cos omega n you can't delay, because you are delaying only your what? Your x of n. Fine. So this is x of n. Okay, then in the equation 1, in the second step, what do? We replace in equation, we replace n by n minus k in equation 1. So this is equation 1, replacing n by n minus k, you will get yn minus k is equal to xn minus k. Now cos, now you are delaying n by n minus k throughout. So you will delay here also, and you will delay here also. So clearly you will see that yn comma k is not equal to y, as here is typing error, it's yn minus k. So clearly these two things are not equal. So when they are not, the system is shift variant. The system is shift variant. Okay, that's all for now. I've also given some problems for practice. Just a sec. So these problems you can try it to your places. Fine. If any problem, you can just mail, or you can just post your questions or queries on the YouTube link. Fine. It gives you the option in the comment. You can just post your queries and questions. Fine. So rest will be linear. We'll be discussing in the next lecture, inshallah. Okay. Assalamu alaikum.